Anybody who's paying attention recognizes that our world is getting warmer. Every year, we run another opportunity, another risk of setting another highest year on record. Every year, energy costs go up. Every year, third world and developing nations are bringing on more people into their middle class, which means more air conditioning. Air conditioning use is growing, will not continue to grow until literally everybody on the planet has access to air conditioning.
So the way it works is your typical HVAC unit at a commercial space, there is supply ductwork that comes there. We cut a space open, we put the chassis inside of it, and essentially through the normal operations of your HVAC system, the compressor turns on, cool air passes through the metal chassis, therefore freezing the metal plates and the PCM within inside of it.
Right now, on a sunny day out in California, my guess is 52 to 60% of the energy in the grid right now is sustainably sourced, which is amazing. It works. The problem is it can't be stored on our grid. So we use the energy, and late in the day when people leave work and go home, you still got your buildings running and they go home and fire up their homes. The demand increases dramatically as the supply from renewable is diminishing. There's no other option except to run up your carbon-based fuel systems. Hence is the problem. We have the ability to attract and capture energy. We don't have the ability to store it and deploy it later in the day. Late in the day, when you have to ramp up carbon-based fuel sources, you can't simply just turn a knob and have the power plants that have been running at low idle all day long to spin up. You have to bring supplemental sources on. We call those peaker plants. They're the most expensive, least efficient, highest emitter of greenhouse gases. From the get-go, one of our goals has always been, we want to know how many peaker plants we can make go away.
Once that takes place, we turn off the compressor and we use the normal fan cooling, so therefore you are still distributing the cold air throughout the space and therefore saving energy, using more sustainable resources, and therefore reducing your energy bill.
The product is liquid in the morning. As the building air conditioners turn on, the temperature comes down, cold air is delivered through the duct, which freezes our panels. The product remains in the duct, benignly sits there until 4 p.m. typically, or the start of what we call peak demand period, which in Southern California is 4 to 9 p.m. during the hot summer months. At 4 o'clock in the afternoon, my building automation system jumps in front of the air conditioner and takes the compressor offline. It uses the fan to continue to waft air through the building and flow through our thermal storage product, which is cooled by our 62-degree ice, providing literally free cooling. When you compare our output as opposed to a standard unit, it's about 80% greenhouse gas reduction. Not only did we end up doing fine in that first CalSEED Concept Award, we pitched at the end of it to win the next award, which is the CalSEED Prototype Award. The CalSEED program for us was seriously amazing. This group of people wants nothing but your success, and they really go all out to help make it happen. I can honestly say that we would not be where we are at today if it weren't for the CalSEED program and all the support they gave us.
This is a load flexibility focused technology that is able to address all the renewables coming in, lets us take more advantage of those renewables, and then meeting the needs in the afternoon to our challenged grid. You get the same cooling for reduction in price. Not only does this reduce the price of your utility bills, but this also reduces the load on the grid, meaning less blackouts for all Californians across the grid. At Stasis Energy Group, we're proud to provide a set it and forget it technology that provides the same amount of cooling as well as reducing your utility bills.
My name is Rob Morton, and I am the founder of Stasis Energy Group.